Okay, continuing with example 2, now what we're going to do is we're going to take the same functions and try to find their domains of these 4 compositions. And you'll see it's going to involve obviously computing the formula for these functions like we did before, but we just have to think a little bit about where everything is defined. So once again, we'll find these compositions. So if we take f of g of x, this is going to be f of x over x plus 5, and this will be negative 3 times x over x plus 5 plus 4. Okay, now we could simplify this a little bit, but in this case we have to be a little careful when we simplify, because we're just asking to find the domain, and we don't necessarily have to simplify it. We can see that we have negative 3 times something plus 4. So as long as this something is defined, we're okay. And this something, it's a rational function. It's x over x plus 5. That's defined whenever x is not equal to negative 5, right? So the domain would be all x not equal to negative 5. Okay. And you can write this in interval notation if you want later on. So that's the domain of this composition. If we go on to g composed with f, this is g of f of x. And this is going to be g of negative 3x plus 4, okay, which is going to be, now we plug this in here, replace x with negative 3x plus 4. So we get that, and now we will simplify this because we have a denominator here, and we want to simplify that denominator, so this is going to be negative 3x plus 4 over negative 3x plus 9. And we see that this will be defined everywhere except where negative 3x plus 9 is 0. And if we solve this for x, we get x equals 3, right? Okay. So the domain will be all x not equal to 3. Okay, so this was the domain of the first composition. This would be the domain of the second composition. If we compose f with itself, you should sort of be convinced that the composition is going to be all reals, because the domain of f is all reals. Okay, and when you compose two things that are defined everywhere, the composition will be defined everywhere. But we can again check. This is f of x. This is f of negative 3x plus 4, which is negative 3 times negative 3x plus 4 plus 4. Which will be 9x minus 12 plus 4, that's 9x minus 8. Okay. This is clearly defined everywhere, so it's all reals. Now if we take the domain of g composed with g of g of x, this is going to be x over x plus 5 over x plus 5 plus 5. Okay, I'm skipping a step here, but you can see obviously g of x is x over x plus 5, and you just replace this x and this x with x over x plus 5. Now before we simplify this, we will see that clearly if x is negative 5, this does not exist. Because if, in that case, this expression and this expression are undefined. So right away we know that x cannot be equal to negative 5. But we can see that we actually have a bigger denominator here. We're actually dividing by something else. We're dividing by some number plus 5. So we also have to worry about this expression being 0. Okay? And so we can do that by setting this equal to 0. It's probably might be a little easier rather than we can multiply the top and bottom by x plus 5. And if we do that, then we just get x over x plus 5, x plus 5. What we did here is we distributed this x plus 5 times this is x plus 5 times 5 is this, and this is going to be x over 5x, actually it'll be 6x, plus 25. Because we have this x plus 5x plus 25 is 6x. So we set 6x plus 25 equal to 0. We will get x is negative 25/6. Okay. So that's another number that's going to cause us problems. And so we have these two numbers here, negative 5 and negative 25 over 6. So in this case, the domain will be all x not equal to negative 5 or negative 25/6. And this is a little tricky point because notice if we just started here and we just simplified by multiplying and dividing by x plus 5 and we got this, it would be very easy to think, okay, well, if I plug negative 5 into here, I'll get something that's defined. But again, negative 5 can't be in the domain. Negative 5 is in the domain of this expression, but it's not in the domain of this expression. And this expression is what we're interested in because this represents the composition. Okay, so that's a very subtle point here. So you can't just plug things and simplify all the way and then find the domain. You have to make sure that everything is defined. All right, so I'm going to let you work on example 3. I'm going to ask you to pause the video and then you can check your work. In this case, you are just finding the expressions. You're not trying to find the domain. That will be, maybe we might do that a little bit later.